All right, so now I finally got this thing set up and working. This is the Windows machine on an Intel processor connecting back to the Linux machine and connecting to the Apache process. So in this case, we're going to exploit this thing called Easy MP3 Converter. And I've got a T318. Okay, I'm just repeating a little of what I said half an hour ago when I started this before we ended up on a long troubleshooting issue. So here's the fuzzer, which is going to find the vulnerability. If I can type there. So this is just going to print 30,000 A's. And I've done that and put it in this file called ezmfuzz3.m3u. And I started an Apache web server, which you can see with sudo ss-pantel. So this machine is listening on port 80. And I put that file where Apache web data goes, which is var www HTML. So there it is, the 30,000 file EasyFuzz3. Now, on the Windows machine, we launched the vulnerable application. Well, first I'll download that thing, which is here, ezmfuzz3.m3u. So now I've connected to the Windows machine, which is also a web server, and I've downloaded that thing. And, all right, there it is. It's got a 1 because I guess I already had one, although I couldn't find it, but that's probably because of Windows sorting things by dates and getting in the way. So now we need to run a debugger and immunity. We need to run the EasyM app inside here, which is already here. It's this C program file, is x86, and the RP converter is in there. So we run it in there and launch it. And because we're on an Intel processor, it moves fast enough and opens up here. And now we're going to load a playlist. There's some kind of networking options. You just take the default because it doesn't matter. We're not using the network features of this application. Now, if you load a playlist that we've downloaded that contains 30,000 A's, you have to choose the second option here. And there it is. So there it is. And when you load it, notice you get our favorite thing, access violation when executing 41414141. So the data we put in entered the instruction pointer, and therefore we can take over the machine. So let's restart the vulnerable app. All right. And now we want to target the EIP. So I've got in the project, I don't think I'll bother doing it because we lost so much time troubleshooting it, but this is stuff we've done before in other projects. Now that you've found an exploit that puts some letters in the instruction pointer, you just need to find out which letters, so you create a non-repeating pattern of characters. And what I made was something that just has a number and then a letter. So it's going to have a capital letter A through J, and then a 3-digit number. So that's going to be 10,000 characters. You have 20,000 A's and then 10,000, 10 groups of 1,000 here. So you'll have a letter and then a 3-digit number. And so now that's find EIP. And when you run find EIP, you find it's this, 30, 38, 30, 47. This is 0, 8, 0, and 47 is A, B, C, D, E, F, G, G. So that's 080G. And so you can figure out how many bytes there are before that, 20,000 before the non-repeating pattern. Anyway, I figured it out here. So the end result, that gives me the one that will target the EIP precisely, hit EIP, the same way we've done it before, and that I have here. So if I cat hit EIP, I figured out this number by using a non-repeating pattern, then I put in B, C, D, E. And then I put in F's after that. So this one should do it. And that, I made another 30,000 length M3U file out of it, which is a playlist. So let me download this one on my target server, which is here. So I'll go back into Firefox and put in the name of my new exploit file, which is hit EIP. Okay, there it is. And now I open that one here. So again, I accept the defaults or whatever these network settings are, load. And in the downloads folder, I look for playlist files, and here's hit EIP. All right, and now it works. Oh no, I missed it. 46, 46, 46, 46. It hit the Fs. So I didn't make it, but maybe I can figure out why. Let's notice here's the Fs. Let's see if I'm close. Here's ESP. So if I follow that in the dump down here, I can see the data. And if I scroll back up, I'm hoping, yep, I only missed by a couple lines. So I'm close. I just need a few more A's. So I should be able to modify this pretty easily. Let's nano hit IP. All right, and let's try.
You change the offset, -4, -8, perhaps?
Yeah, I could try adding something to the offset, but I think what I'm going to do is I'm going to add. Eight that way, and then I'll have digits to look for. So if I'm within 8, some of this will hit now. So let's try that, and then run hit. Okay, and then put that in a file. I'll just call it hit.m3u, and then put that in the Apache folder. Okay, now I can download it on the Windows machine, hit.m3u, which is here and here. Okay, so I can just trim this. There. Okay, I've got it. Now I can open it in a vulnerable app, but I have to restart it first. Restart. And run. Okay, that should launch it. Yep, there it is. And now I should be able to load, agree to whatever the default networking settings are, and load, in the fullness of time, there we are, playlist files, and come on, playlist files, there, and hit OK. And now I get 4, 5, 6, 7. So now I know where the EIP is. It's wherever 4, 5, 6, 7 is. So I can fix this. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, that's what hit. So I need 4 more.
So -8.
85. That should do it, and then get rid of all this. That should hit the EIP with BCDE. So let's try that. And I'm going to make it hit 2.m3u. And I'm going to put hit 2 where the web files are, and then download hit 2. And, you know, this is, I did try this at home on Windows 11, but probably with a different service packer. I don't know. There's always small differences between machines. This is very common. So the thing that worked there didn't work exactly here, but it was close. So now I do debug, restart, and get past all the warnings and run it. And that will launch it. And then ask me some nonsense about networking. Okay. And now I load the playlist of hit 2. And now I finally get 42, 43, 44, 45, which is BCDE. Now let me get my window here so I can see if there's comments in the Twitch, which I've forgotten about. Good, okay, just a couple of old comments, nothing too drastic. Okay, so now we finally found the EIP, and now I think we can look at the memory at ESP, and you'll find there's 4F characters before the EIP. So if you go to ESP here, you can see it's pointing to a bunch of Fs. If you dump it in the dump down here, there's the Fs, and if I go up one line, see these 4 Fs here. So here's the instruction pointer. There's 4 Fs, and then the ESP is pointing here. And remember, we have address space layout randomization turned on. So we're not going to be able to target this address directly. This address is random. But if we use an ESP, we can find it in the code we've injected. So now we will make, we're going to list modules and find a module that is not moving. So it's bang Mona modules. And so this is going to find all the running modules, and there they are. And I would like to scroll up if I can manage to do that. Let me, if I can use this, this will work. Okay. So here's all the running modules and which defenses are turned on. Okay, and in particular, we don't want ASLR, and we probably don't want rebase, although that's optional. Rebase means it has the ability to be relocated in memory, but it often isn't relocated. And notice we really want one without ASLR, and you see there's only a few modules without ASLR. And this one is actually a contender. It's loaded at 03F8. We could use that one, but anyway, the one I'm going to use is the one we've used before, which I'd like to scroll to the right if that was possible. Let's see if I can make this. I'm having trouble getting. Oh, here we are. Read it to the right. There. All right. It's ones with ASLR turned off. There's this one, MSRM filter. Let me check my my project. See which one we use. It was MSVCP60. Wait, finding a module that doesn't move. All right, we'd really like to find one with ASLR equal false and rebase equal false, but we don't have that. The only module like that is one that has a null byte in its address. So let's take a look at that. False, false, there it is. Here it is, MSR13, but see that one loads at the address 100 million or something, and so it always has, well, 1007, I'm not sure it's going to always have zeros in its address, but I was worried before that it might. Now I'm not so sure. 1007, 1000, there might be some parts of it are going to have 1000, then it's going to have 1001 up through 1007. So I don't know, some of them might be able to find an address there that doesn't have a null byte in it, but what I did was go to MSRM filter 03, because even though it has rebase enabled, in practice, it doesn't seem to use it. It doesn't, I tried running it 3 times, and it didn't move.
Is peculiar to this library?
Yeah. So this library also has the property, MSRM filter 03 is the one I used before, and that's what I'm going to use again, MSRM filter. I'm looking for the false ones. That's a codec. And there's filter 02. There's a codec. There's a WMA timer. There's a converter. I just wondered if I could find it. Supposedly I found one, MSRM filter 03. This time I'm not finding that module. WA timer, MSRM codec, MSRM filter 02 I found. And MSRM filter 01. Here it is, MSRM filter 03. There it is. And that one actually has false, false. So it's got rebase and safe say. So that's a good choice. Anyway, that's the one I decided to use. And you find a jump ESP with this command, and I found one useful address. This command takes a while. I'm just going to accept the answer. But this, let's see if it's 1001 B058. Yep, 1001 B058. That's right, it looked good. Oh, this is the one I was talking about before. As long as you escape the first block, this will have addresses that aren't 0. So there's an address here, which will be a jump ESP. And let's see if I can verify that. If I go back to CPU, I should be able to go there. Let's try debug restart, because things are sort of frozen up on me here. All right, and go to expression and feed in that address. Nope, can't get there. Yeah, I was afraid of that. I'd have to, that's a library. I'd have to somehow get into the DIL. And I'm not sure how to do that in debugger. I have to attach to the DIL. So anyway, I should be able to now test code execution that way. And that's what this EIP4 module does. Let's see if I have that in here. And looks like I don't. All right. So let's put it in here. Let me copy. It was hit dot hit. EIP is the one that worked. And this is going to be EIP4. All right, I want to modify this. There, the EIP, this is the stuff I want to add, but I want to keep the prefix from this one so it'll work. There. There. And now let me get rid of the colors that I can't see. That's minus Y none. Okay, so this is going to, there's the EIP, 1001B058. Then it has to skip 4 bytes. Then I put in the NOP sled and a break. So this will show I have code execution. So let me run this. It's called EIP4. So let's EIP4. Oh, yes. And I've got to make it use parentheses for Python 3. All right. Okay, so I'll put that in a file. I'll call it EIP4.m3u and copy. And I need sudo to do that. All right, so now it's EIP4.m3u, and I can download it here. Okay, there it comes. So now I can load it in the immunity. So debug, restart. Well, I think I already did this, but it doesn't hurt to do it again. Then run. Okay, now answer the stupid question about networking and load EIP4. Okay. All right. And now I get an access violation when executing this, which means data execution prevention has stopped me. And if it stops at a NOP, you have data execution prevention turned on, so I'd have to turn that off. So anyway, that's the main point here. I guess I'll try it again. Let's see, avoiding bad characters, generate exploit code. That's the point of this one. This one here, we're not dealing with data execution prevention here. So I want to turn that off. Might as well do it. It's advanced system settings. Now let's see how difficult we make this. Computer properties, advanced system settings, okay. Wonder if I can do this. Advanced system settings, oh, that's nice. Okay, so I can go to performance. Well, actually, I don't need that. I need, all right, where is it? On the advanced tab in the performance thing, click settings. Okay, it was there. There it is, DEP. There we are. So I have to have it for only essential Windows programs, which is the typical client version. I must have turned this on for some previous project. So now we have to restart this machine. Let's get that far because this is the part that proves that it's actually working. Now we restart it. All right. All right. And it'll probably take another few seconds to restart.
Sam, when
Yep.
we in the projects when we need to locate the pointers or we need to play around a little bit with the addresses, so we usually customarily add or subtract 4.
That's true. It seems to be that way, and I don't know why. I think it's just.
Well, because
Yeah.
4, I thought 4 was the half a a byte.
Well, that's true, that could be it, yeah.
So it could be the unit of
Yeah,
memory.
yeah, that's probably a pretty good argument, yeah.
But I'm encountering also on the book, adding 14, 11, 13.
Yeah.
That, it doesn't matter then, so why this?
Yeah, I don't really know. I just know different versions of Windows have all changes required.
Okay.
But you're right, probably the most common change would move it by 4, because it'd be on a 4-byte boundary. Anyway, now, the same exploit should work, so all I really need to do is run the debugger. I don't need to download anything new. I just need to run the program. All right, and then load that same file, and it should make it through to the int3. So it's going to ask me some question about networking. And EIP4, okay. And now I'm still getting access violation, which is pretty disturbing. So something is still wrong, and I don't know what it is. And when executing 01, and I don't know what this address is either. That's not, let's see. Nope, this is pointing, yeah, so something is wrong. Maybe I made some kind of mistake making that Python file. The rest of it should be normal. Let me see if I can track down the mistake. I'm not finding it. If I look at hit EIP, that's not the right one. It was EIP4, okay. All right. 1001B058. Maybe this is different on my machine. That could be a problem. But then it would crash at this, and it'd be 1001B0 would be where it's crashing, and it's nowhere near there. So, however, I'm thinking, just for completeness, let's see if we can fix it. Maybe I have to find the address here. I can't use my previous address. That could be on this different version of Windows. So let's try running this Mona jump command. Let's see how slow it is. And find an address. That's the most likely problem. So I run that command, and there it goes, searching. Typically this takes quite a while, but maybe not. Oh, it's done already, good. Okay, view log, okay. Found one pointer, all right, and there it is, 1001B058. It is the same. So that does not explain what the problem is. Let's compare that to my code. 26085, 1001B058, FFFF NOP sled. And the one that hit the EIP was the same. Hit EIP. That was 26085. 26085. Well, skip 4, then NOP sled, int3, padding is 30,000 minus the length of the prefix, minus 4, minus 16, why is an extra minus 4 here? The EIP. The EIP is 4, the skip is 4, 16 is the NOP, and 1 is the int3. Yeah, let's see if my attack string looks right. It should be 30,000, and it is. Oh, look at this, it's the wrong length. EIP4 is somehow off by 19. That's interesting. Okay, that's the problem. I'm off by 19 somehow. 30,000 minus length of prefix minus, this needs to be updated to Python 3, which I thought I did. I wonder if I can refresh this. Yeah, you got to have these bytes. Because I didn't refresh the browser, I had an old version of this, and the 2685 is right too. Ah, now we're getting somewhere. Okay, it was because of the difference between strings and bytes in Python. So that's what I thought. Because I didn't refresh my browser, I had an old version of that. I wondered why things weren't working, because I fixed this up just a couple days ago at home. All right, there. That's the Python 3 version. See, everything is byte arrays instead of strings now. That's why it was 28. It was putting in this literal \x58, putting extra characters in there. That should do it. Okay, now, if I run that one, yep, now I run that into my EI port M3U, okay, and then sudo copy there. Now we should be in better shape. Now I go here, and I go to Firefox. Let's restart this one. Okay, Firefox. Okay, now I need to get the address of my Linux server again, which is this, ending in 115, okay. And I need to go HTTP. Good. And now it was EIP4.m3u. Okay. It's the one with a 1 in it. So now I go to my debugger and run this. Okay, now I load. The latest one, which is this one. And if I look at the length, I should be able to tell from the length. Oh, it doesn't show me the whole length because Microsoft is very cruel. All right. So now when I run it, now I get the int3. That's what I wanted to see. So and it keeps popping up ads because Microsoft is horrible. So int3 is down there in the corner. I can't point to it or Microsoft will fill the screen with ads. But up here you can see it and you can scroll back and see there it is. It executed the NOP sled and it hit the int3. So now we're on the road. So that's important. That shows what went wrong here. All right. And so that's the benefit. And now you do stuff we've done before. You check for bad characters. You generate malware with MSF Venom, and then just inject it in there, and you can run it and open a shell on your machine. So, all right, it's took a long time, but that's the game, and you see the sort of stuff that goes wrong. Most of it was never troubleshooting, but yeah.
int3 was the block, was the stop, the break.
Yeah. The problem was I had Python 2 code that used strings here instead of byte arrays, which is what you have to use in Python 3. So it was putting this stuff in literally, instead of interpreting that as the hexadecimal value 58. Okay, good. So I'm going to stop this recording and